You've tried using Lovable, Bolt, Replit, Cursor, or any of these AI coding tools, and let me guess, you got super excited at first because you were told that you were never going to need to hire a software engineer again. That anyone could become a software engineer overnight, and that you could build the software of your dreams in the matter of days. Now, this promise seemed incredible, partly because it was, but this is exactly why these tools have taken off so rapidly. But you hit a wall. Bugs start creeping in, things aren't quite how you want them, and every time you ask for changes, it breaks something else or it alters too much. And you realize that the progress is stalling in your project as the complexity begins to rise. Now, this is what happens when you hit the fundamental limitations of how these tools actually work. And let me tell you right now, this is not your fault. My name is Timothy Hynum. I'm the CEO and co-founder of Seven Sigma. We're a tech studio where we're building MVPs, SaaS, and AI applications for our clients. In this video, we're going to break down exactly how these AI coding tools work under the hood, and specifically how large language models drive them. I'll go over a framework to show you what these tools are great at versus where they fail completely, and then using that understanding, we'll cover what you can do about it. So you can stop wasting your time hitting the same walls and start to make real progress on your project. So, to start, how do these AI tools actually work? Now, when I talk about AI, I'm referring to the AI that everyone's talking about, which is particularly generative AI and particularly, again, LLMs or large language models. Now, the key thing here that you need to understand is that AI and LLM tools like these are not reasoning tools, by which I mean they don't actually think. What they're doing is they're memorizing a load of patterns from their training data and then predicting the next word or the next piece of code that is meant to be. Effectively, these tools, like their role is understanding patterns and then stitching them together, predicting what you would expect as a result from your prompt and any other context that it has available, which is usually, in these cases, the rest of your code base. Now, ultimately, again, Lovable, Bolt, Replit, all of these tools, they're just a nice interface and way for you to interact with the same underlying technologies. Now, the issue with this approach is that, as I said, they're not really thinking, right? And it's not just me saying that. There's a paper from Apple called The Illusion of Thinking, which effectively is saying that these tools, they don't reason for themselves, even the so-called reasoning models. What's actually happening is they're good at solving problems by just replicating the solutions that they find in their training data. Now, it's not actually thinking up a solution. It's a bit like trying to solve a riddle, not by thinking it through, but by remembering the solution to a similar riddle you've done in the past and then just trying to adapt that solution. It might work, but it's only going to work for either simple or very, very similar riddles. Now, the issue with these tools is the same kind of idea. Is if what you're trying to do, if it gets too complex or too different from anything that's done before, it's going to quickly become useless. And what that means for coding is when you ask them to do something, they're looking for similar patterns in their training data that apply to what it is you're asking them to do. Let's say, for example, you want a web application, and it's going to have a landing page, a sign-up flow, and a dashboard. What it's going to do is it's going to go to training data and figure out, okay, what is a landing page? What is a dashboard? What is a sign-up flow? Start stitching those things together in something that follows, roughly speaking, what you're asking for. Now, this is not at all the approach that a normal software engineer would take for your project, which is very significant. We'll come back to that later. The key thing to understand is LLMs are not thinking about what you want to do. They're just thinking, they're almost taking a step back, and it's saying, okay, what is likely correct based upon what you've said and based upon its training data. Now, you might also hear about agentic AI, which is basically just LLMs that have agency. What does agency mean? It means that they can go and they can perform actions on their own. So an agent can actually go and do things. So in this case, instead of it giving you code, you can write the code, test it, look at the results, and then make changes automatically. So you don't need to be supervising it quite as much. You can run a bit more independently and it can do things by itself. However, the agent still has the same fundamental limitations as the LLMs. It's not thinking, it's just copying patterns. So even if it's able to do more automatically, if the reasoning, if the thinking isn't there, you're going to have a very busy system that spins in circles, making a lot of changes to your code without really solving the problem or issue that it's ran into. And you've probably experienced this, where when it creates or causes a bug, you say, hey, fix it, and it tries to fix it and it's unable to. And it just tries a different approach, and it tries a different approach, and it tries a different approach because it doesn't know what the actual solution is. It's just trying to fit the closest pattern it has in its data and say, maybe it's this. It's not this, maybe it's this. And with that kind of fundamental understanding, let me share with you my framework for what these tools are good at and what the problems that they're great at solving, the problems that they're not great at solving, and how to tell the difference. Because the problems you'll be able to solve very well with these tools are things that are known as very low complexity and with low levels of interconnectivity. Now, what I mean by that is you can have a project that's very wide, but the complexity stays flat. Now, none of the individual pieces of that project might be complex, and one of the main things that makes it complex or not is how much they're having to talk to each other. So let me give you an example here. So imagine a website, and this website's going to have 20 pages. And each of those pages is going to be somewhat independent. Now, just because the website has 20 pages doesn't mean it becomes 20 times as complex. Now, it might take 20 times as long to build because you spend an amount of time on every page, and with 20 times as many pages, it takes 20 times as long to build. But the complexity of the overall website is not increasing. Overall, what's happening is you're just extending the same simple thing again. And we can compare that to, say, 2 pages, where the second page is going to get information from the first page and vice versa. Now you have 2 pages, but there's 2 different ways data needs to flow. And what you're doing, and if we start adding more pages in, is you're going to see that as we grow this application, complexity doesn't just increase by 2 or 3 or 4 times, it increases exponentially. So for example, we have page 1 connects to page 2, and page 2 connects back to page 1. If you add in a third page, now you have connections between page 1 and 2, 1 and 3, and 2 and 3. So now you have 6 connections. If we add a fourth page, you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then, if you keep adding pages in this manner, you see very quickly how the complexity starts to build up. Now, what AI coding is really good at is things that have a very low complexity threshold. They have very flat complexity profile, like our website, and not like our application. So even if you're doing many things, if they don't talk to each other much, it's probably going to have to do a pretty good job. So the AI coding tools are great for 2 things: basic websites, like the example given, or visual prototype for applications. So basically early mock-ups or other early versions of an app that look real, but they don't actually have the underlying complex functionality behind them. So anything where you can keep adding building blocks on without them needing to communicate to each other is going to work very well with these AI coding tools. And that's kind of the first category of where these AI tools are really useful, because the AI doesn't need to be smart. It needs to be able to keep adding on. Now, the second thing that these tools are great at is replicating patterns for problems that are already solved, aka very common problems. Now, in software development, engineers are constantly solving problems. And when I say problems, I don't mean, or maybe perhaps what I do mean is something like, how do I verify someone is who they say they are? User authentication. Or how do I let users reset their password? And when I say solved, I mean there's very clear, established, and well-tested ways for how to handle these challenges. And they're known to work reliably. So authentication, for example, this is a solved problem because there's proven methods that millions and millions of applications already use successfully today. Other examples include API connections and connectivity, user registration, password reset flows, many things that just have standard solutions that you don't really need to think through. You can just take an off-the-shelf solution and then you can apply it back to what you're doing. And they're not even necessarily the best approaches, they're just the most common way to solve the standard problem, which the AI has probably seen thousands and thousands of times in its training data. And so that's what I see these tools being really good at. Either doing things that have a low complexity threshold, where you can just add something onto your app or website and keep adding and adding, it's going to do well with that. Or if you're asking it to solve a problem that's already very well known, like how do I authenticate a user? How does a user reset their password? Those kind of things you'll probably be able to implement very well. But there are, of course, limitations. And the same downside of what we just discussed as well, it's good, is every project is going to grow and every project is going to end up increasing in complexity over time. As it does, you're inevitably going to run into the fundamental limitation that we've been discussing. These tools do not think. They just repeat patterns from their training data. And this shows up three main ways that it's going to cause you problems. First is any kind of complex custom logic. When your project needs something that's logical and nuanced, or requires combining existing pieces of how something works in a way that's not really been done before or not done often, the AI is going to try. It's going to stitch together patterns that it's seen, but it maybe won't make sense in the code. And that's not a problem with your prompting. It's simply that the AI can't reason through the problem very well. And what's happening is that then you get bugs, and the AI simply can't overcome them. It's going to keep creating the same logical errors over and over, no matter how you prompt it. Second is anytime you want to deviate from what's common or what's standard. I can give you an example from my own experience. So at 7 Sigma, we have specific ways that we like to structure our code. We have our own guidelines about how things should be organized and how things should be built. And when we've tried using Cursor and we've fed it all our coding guidelines, it's worked great. So long as it aligned with our coding guidelines with the common patterns. But the moment that we needed something that deviated away from the norm, even though it was the right approach for our project, it became very hit or miss. And the AI could not consistently follow the guidelines if there's any that conflicted with what it had seen most often in its training data. Now, this applies to anything unique that you want. Say unique design patterns, unique user interfaces, or unique ways of organizing your application. Unless the AI has seen that exact approach thousands of times before, it's probably going to try and force fit the closest common pattern it knows. And when it gets close to what you want, it ends up breaking other things and then doesn't know how to fix them. Now, this isn't necessarily a problem for prototypes and MVPs, so long as the functionality that you want is somewhat common or relatively simple. But it will make it hard to build something that's differentiated. Now, to be fair, I think the first issue, which is not being able to do complex logic, is actually the bigger problem of the two. Then there's the third major issue, which is certainly the biggest. AI does not create maintainable software. Now, what I mean by maintainable is I mean that eventually, due to issues 1 and 2, you're going to either need to involve yourself or hire someone else to take over and begin updating the code manually. This is how you're going to fix bugs, how you're going to add new features, and how to make the software more scalable so you can have more users. Now, this goes back to the idea of AI Frankensteining or stitching together different ideas in unique ways without fully understanding what it's doing, which is what we were discussing earlier. And the problem is that this approach is the complete opposite of proper software engineering principles. Traditional software engineering principles were built to help humans to better build and maintain software, designed with the advantages and constraints of the human brain in mind. So, for example, a talented software engineer typically has quite strong reasoning capabilities, but they probably don't have the ability to remember everything about where all the little details are located across a very large code base. So, traditional software engineering follows principles like don't repeat yourself, have structured code, modularize the code by, for example, putting logic in one place and then putting UI in another. So that every time you want to change something, you need to change it in one place and it impacts everywhere else that it needs to go. Now, these principles were designed to prevent humans from making mistakes. However, AI works in a completely different manner, and it breaks all of these traditional software engineering principles. AI only has a limited context, so it can only understand and work with a very small portion of your code base at any given time. Because of this constraint, it ends up mixing the logic and visual elements together in each component that it creates, rather than keeping things separate like a good engineer would. Now, if we take the example of a SaaS application, a human engineer would typically separate how a dashboard's logic, which is how it processes the data, would work from how it looks, which is the UI. But the AI is going to look at and build your dashboard component with everything mixed in together. The logic, the visuals, and all the data processing is all going to be in one place. And it's the same thing with your database component, your settings component, and so on. Each piece becomes completely isolated from the others, which creates two big problems. First is the same logic gets duplicated across multiple components because the AI can't see the bigger picture. So when you change how something works, the same logic might be scattered in 5 different places, but the AI and you won't know where all of those are. That can introduce bugs and cause all different types of issues. And second is it becomes incredibly hard for any human engineer to take over and work with the code. So in industry, this is called spaghetti code. It's like a big pile of soggy spaghetti on a plate, and figuring out how the code is built, why it has bugs, and then fixing the code is going to take a long time. It's going to be a slow process. And it's not going to be a good foundation to build anything substantial on. So to summarize, these tools are good for low complexity tasks. Things that are very flat, things that are quick builds, or things that follow very clear and well-established patterns in how they should work. They're not good for complex logic or things that require specific guidelines or things that need to be maintained long term. Obviously, the bigger and more complex your project gets, the more these limitations become a real problem. So, what can you do about it? There's basically 2 solutions. Solution 1 is you need to learn the fundamentals of software engineering. Now remember, AI is really good at memorizing patterns, but they're not really good at thinking. So if you, as a user of these tools, can learn those fundamentals and learn the language that the AI is using, you're going to be able to fill in the gaps in the logic and the reasoning. You can correct the AI over time and correct it anywhere where it's falling short or introducing issues. You'll be able to spot them, understand that's going to be problematic, and then stop it from occurring in the first place. Now, obviously, this approach is going to take patience. I know the initial promise of these tools was that you don't need to know software, but we've seen that inevitably you do. You actually need to know software to get the point where you can correct these issues. And the better that you get with software engineering, the more you're going to be able to catch these problems early and then start to modify them. And basically the runway or the advantage that you're going to get from using AI coding tools is going to become much larger. If you can prevent the issues from happening earlier on, you'll actually be able to create more complex applications and go further than someone who doesn't know any software engineering at all. However, at a certain point, you will probably end up just doing some of the software engineering yourself because it's going to become more time efficient. But that's the first solution. Solution number 2 is bringing in someone that already knows it. Because if it's inevitable that you are going to need some software engineering knowledge, then bringing in a co-founder or some form of tech partner is going to be necessary if you don't want to be learning all the stuff yourself. So you'll need some kind of technical person to take over your code, clean up all the AI-generated mess that you might have created, and then take it from there. Now, unless your SaaS or software is super simple, very scoped, meaning it's very limited in what it needs to do, and then it has a very flat complexity profile, you're probably not going to get away without having any technical expertise. It just simply won't work reliably, not today. So all these AI coding tools, again, Lovable, Bolt, Replit, Cursor, they can be incredibly useful for getting started quickly, especially for simple projects with common known patterns. But they are not the magic solution that eliminates the need for software engineering knowledge or technical expertise. And understanding these limitations up front is going to save you a whole world of frustration. Using these tools, use them for what they're good at. Prototypes, simple websites, common functionality, but plan for when your project starts to grow in complexity. The promise that anyone can become a software engineer overnight, it's just not quite there, but these tools can definitely accelerate your journey if you use them wisely. Thank you for watching, and if this has helped clarify why you've been hitting those walls and those issues, let me know in the comments. If you're dealing with these exact issues in your project, feel free to reach out. This is exactly the kind of problem that we at 7 Sigma help solve for our clients. You'll find more videos on this topic and on my channel, as well as other resources in the description of the video below. Thank you.